Hari sir, yeah. Himans, now it's very good afternoon to participants. So morning we had session from Himans Pusparo about the overview on blockchain and big data. In continuation of that one, today we are going to have a next session, which is going to talk about how the blockchain transforms the big data. I would like to invite Mr. Himansh Kumar, JRF Research Scholar of Department of Computer Science, to introduce about Mr. Hariharan.
Good afternoon, everyone. Good afternoon, everyone. Thank you so much, sir. It's a great honor for me.
Louder. A little bit louder.
Okay, sir. Good afternoon, everyone. Thank you so much, sir. It's a great honor for me to introduce and welcome Hariharan Ramalingam, sir. Sir is a senior manager, delivery assurance, Intel, high-tech sector at Wipro Technologies. He has 20 plus years of research and development industry experience covering IT product development in India and abroad, startups and MNCs. He is expertise in cloud infra-based solutions, private and public firms for large enterprise and SMB. Embedded system, he has expertise also in embedded system design, software architecture, enterprise standards, career class product development, lean methodology, and low cost product development. He has executed PDLC, SDLC from concept, POC development, and launch of products. And he has done competitive projects with MNCs on SoC development for next generation mobile computing and artificial intelligence and 5G technologies. He has implemented design for manufacturing and serviceability in products to support global manufacturing and service hubs. He has managed and achieved sales volume for more than million units of products in server line based on competitive and requirement analysis. He has built, trained, mentored teams globally for product development and audited, implemented ISO 9001 practices, quality standard for software development practices in global everything. He also managed software and hardware vendors in Taiwan, US, China, Japan, and India, and enabled them deliver complex product lines. Product lines. He has published paper in international journals on server design, Internet of Things, remote management for server platforms, and security in edge computing. And also he holds patent in telematics-based algorithms for automotive applications and currently working on a patent related to edge computing. Now we welcome Hariharan Ramalingam sir to grace this FDP program by his kind words. Over to you, sir.
Yeah, I thank everyone for this opportunity. Specifically, I wanted to thank the participants for the session today. Let's continue the session from morning, what we have learned. And I expect this to be a continuation. However, we will touch upon some of the basics just to make sure it's a refresher from the morning. Srinivas brought a wonderful insight into big data blockchain overview. So more from there were very good use cases also mentioned. So similarly, we will have it here. It's not a repetition, but rather it will be a refreshing one. I assure you that. With that, let me know if you have any other questions. Otherwise, I'd like to go and start the presentation.
Sorry for the interruption. Actually, for audience, today you have a wonderful resource person. Himans has given an introduction about sir. At present, sir is working with Wipro, and he is having a lot of hands-on experience. He is very much interested in giving presentations, giving live demonstrations. Already in the Karnataka, sir has worked with the government to implement the smart signaling system. Really, this session will be eye-opening. You can enjoy a lot. So with this small note, I am once again welcome Mr. Hariharan to start the session.
Thank you, Dr. Martin. Okay, I hope all of you can see my screen.
Yes, sir. Yes, sir. We are able to see us.
Okay. This is a simple analogy. You might have think it's a nice moon in a evening session. It's not like that. It has a basically a electricity generator, more renewable way and sustainable way. You can see the propeller there, a river is crossing, and then you will have the power coming out. So this is the future, and we look forward for that. I request each of you, when you become good engineers, you should think in more of a sustainable product development. Okay, with that, let me go inside. So today our content will be first on the evolution part. I think Srinivas touched upon this, but I'd like to still stress it again. And then we'll let it go into the blockchain concepts. This will be more on the practical side. And big data, again, I will touch upon some practical concepts. Then the transformation, how it is all coming together. I'll spend some time on the tools. Then we will step inside applications and use cases. And finally, we will have future opportunities. Then probably I'll have few value adds presented in the last session. I don't want the Q&A to be last. You can interrupt me after every section, because consuming this much of data inside your mind, probably you may be reserving your questions and finally not asking. I suggest in between the sections, not during the session, but in between the sections, I will pause. You can still ask me whatever you have in your mind, and then we can clarify it then and there. Okay. Any questions here? Okay, if not, let's move on. Okay, we'll start with the evolution. The internet, basically the growth and current trends, how we have matured and what it has become, and how it has become part of our life today, and without which we cannot do many of our activities. Okay, so it was born in 1969. Basically, why it was born? Again, in response to the launch of Sputnik in 1957, the government, the US government thought we should have competitive technology like Russia, and then they went and did some research. And after a decade of research, they came up with internet in 1969. That's how it was born. It's a more of a reactive approach, actually. Yeah, ARPANET was the first one, and it came out as in October 1969, mostly in a closed network inside US military. But later that's the first insight of internet. And then our first communication was made over a 50 kbps AT&T line. That was the first one. Can you imagine? Now we are in much larger scale. And I know Professor Prasanna was talking in the morning of giving a vision for next 5 years, how it could change the landscape. It will be true because the rate at which we have grown, most of the modernization will start overlapping even before we think, right? It will be just coming to us, and probably, who knows, we may even sign up a e-voting system. Moving on, then we have the TCP/IP invented by Robert Kahn, Winton, and others, replacing ARPANET, and the rest is history. I don't have to say that, right? I just want you to understand the landscape, how we have grown from that point till this point. Okay, now there's so many technologies came now, and now they have bridged us into something more than what we can imagine. I think with reference to Srinivas' presentation, you can see the data, how we are able to categorize it, classify it, and now gone to the level of predictive analytics, right? What is going to happen? What is the probability of happening? All this has come into reality. So that's the thing, and still it is improving. Still, your CPU speeds are increasing. What has been happening in a complete, a large scale unit today is just in the front of it's in the hand of. I mean, each of you carrying a mobile phone, which is having a CPU which can do the same job. 30 years back, that was happening in a large room, like so. That's the kind of computing power you have it in each of your hand today. So the growth, we cannot deny, it is happening, and it's up to us to adapt to the change. So it's racing us. That's what I'm trying to say. So you can see the evolution. First was Web 1.0, and then 2.0, and then 3.0, and today we are into Web X.0 or 4.0, 5.0. The first web was more of a read-only. The second had read-write opportunity. The third web 3.0, moved into portable and personal. And today it's dictating us what to do. It has become like that now. So it is also guiding us. So, and yeah, the first one was company focus. Second one was in a community focus, then individual focus. And today it is more driving a society by itself. Owning a content was the first one. Sharing the content was the second one. This is where the Facebook and everything came. And then consolidating content and then moving into knowledge management is the next one. It's already happening. So I don't want to say next one, it's already current. Yes, we have the technologies like HTML in the first one, XML, and RDF has come in 3.0. So this is more of evolution where you see that just from the click and see web pages or even the computing engines interacting with us through the front-end interfaces. Today we have languages which are more resource managed and much more intelligent. That's how we're going to go. So as you can see the graph in your right-hand side, it starts with all the way from Web 1.0, which is a pure web, and you can see the social web. I think you have experienced every social aspect of it. That is Web 2.2. Semantic web is where the AI and all the intelligence come into place. That is 3.0. And meta web is where it is going to manage the knowledge. So the knowledge management is going to happen. From the individual management, it's going to be a society management. And you will see more technology front-ending us or giving the way of what we should be doing. So that's the way it is. Okay. Now with that, let me go to the next page. Okay, having told all these things, I also want you to practically see what is really happening. Now you can see a snapshot in the left. Now this is the picture of, you wouldn't believe it's the picture of our internet, a snapshot, the visualization in 2005. Each of those routes like branches is basically the IP connectivity happening. And you can see the clusters and little clusters as well as a lot of connectivity happening. Maybe there are a lot of centralized approach happening. And what you see to your right is what the today's internet looks like. You can see a lot of clusters. You can see a lot of distributed computing happening, right? Now, each of those clusters, I'll explain the next page what it is all about. But the internet density has grown so high, and definitely there's a revenue model behind it. Definitely there is so many livelihood behind it. That's the reason it has grown so much. And it's quite amazing. And this project was it's called Opte project, and the group Opte group, they are primarily into bringing up this visualization, and they do it continuously and constantly every year. So this is the snapshot which I thought I should bring it up. It's not just talking. I also want to show you the reality, what's really happening around the globe. This is how your IPs are looking, and more clustered, more growth compared to what we were, say, a decade and a half before. Okay, let me go next. Yep, this is basically the color coding which I've mentioned. Some are US military, some are Asia Pacific, some are North America specific. Those are a lot of clusters of network which are happening. Now let's see what are those actually. Now this is one magnification of our neighboring country, and you can see how many organizations have grown from the point which I've showed you. So you can see the Chinese telecom, their clusters, their IPs, how it has grown. You can see Baidu there. You can see other networks like Shanghai Telecom. Everywhere it's growing, and even it is growing further. But this is just a real-time projection of the Chinese organizations and their networks, how much it has penetrated, internet has penetrated. With that, let me go to the span, like how will it look? Okay, I'm going to play a video. I hope all of you can hear it. Let me know. This is from 1997 to 2021.
Sir, voice is not coming, sir. Voice is not coming.
It's not coming?
Yes, sir. Yes, sir. Just click the share and optimize the voice. You can stop sharing and again you can click the button share.
Okay, I hope all of you have seen it. Can you hear me?
Yes, sir. Yes, sir. We are able to hear.
Okay. Now I just stopped here. Before I want to go into blockchain, I want if there's any questions, I want to know if there's any questions on the evolution. I can't see the chat now. If any one of you can read the chat, if anybody is typing a question, let me know.
Nothing, sir. In the chat, nothing, no messages, sir.
Okay. So if no questions, let me go into the blockchain. So we will cover blockchain concepts, types, and platform. Okay, about blockchain, I think Srinivas gave quite a good insight. However, I want to do a refreshing on the same side before I step inside the integration. So basically, it's a shared immutable ledger. It facilitates the process of record transaction, tracking assets, business network. The assets can be your house, your car, I mean, anything, cash or land, anything or intangible like IPs, patents, copyrights, everything can be tied to blockchain. You can see from morning presentation, you would have seen how much of blockchain has penetrated into the government organizations. Every asset, I mean, I think they have then they also know the census or data on the cattle count in certain part of the countries. So that's the level of penetration it can have, and it has already happened. So we should know what is blockchain and how it is can be used to our I mean benefits and how we can solve problems using it. Just wanted to emphasize on the consensus protocol because that's the backbone, basic backbone of blockchain, and I just want to revisit that part. It's the algorithm. Basically, it's a procedure where all the peers of blockchain network reach to a common agreement about the present state of the distributed ledger. As you know, blockchain works on it's a decentralized mechanism where all the nodes will nominate or rather arrive at a consensus for any given transaction. That's how it works. So consensus algorithm is the fundamental of blockchain, and there are different types. You can see proof of work, most popular usually, and proof of stake, and then delegated proof of stake, and the proof of authority. There are different types. However, the concept is same. It is a consensus among the nodes. Nodes can be any servers or end terminals, which basically has this hash algorithm running, and it creates a crypto link between each node A to node B to node C to node D, whatever. And then depending on the number of nodes, and the consensus is what drives the transaction. So that's the fundamental. I just want to mention it. Okay, with that, the features of blockchain that differentiate from the normal internet is its transparency, decentralization, immutability, ease of tracking information, security, peer-to-peer interaction, and there's no third-party interference. Which you can say is it a closed network? Yeah, kind of. It could be a closed network, but again, it also offers there are types of blockchain which we'll cover shortly. It's also public versus private. Now, given these features, that makes blockchain unique from internet. Okay. Now I know you saw the evolution of internet. Those branches which came, which clusters which came, Now, each of those clusters in web or meta web, which you saw initially, it's going to take its own way of building more secure network. Okay. Now, blockchain is going to facilitate that. Okay. Okay, let me move on to the next page. Yeah, this is more a simplified presentation about blockchain. As I told, it has got a digital ledger that keeps all the records of each transaction happening in the place on a peer-to-peer network. And all information transferred via blockchain is encrypted and every occurrence is recorded, ensuring immutability. That's what is immutability basically. It is decentralized so that there is no need for central certifying authority. And it eliminates a single point of failure also. Then the transfer of currency, contracts, records, any other kinds of data can be done using this platform. I think Bitcoin is one good example. And then we have this encrypted information that can be basically that's what I call as a crypto link. All the information encrypted, shared across multiple providers with pseudo-anonymous alias identities, reducing the risk of privacy breach. So since it's by itself, it is having a consensus within the nodes. There's no way a third party can come inside and breach. So that's the way it operates. Okay. Moving into the characteristics, you can see it is resilient. Each transactions are verified. For example, Bitcoin mining, and that's a perfect example. I'm going to revisit mining also so that you understand how it works. People from anywhere around the world can transact in a large peer-to-peer network without centralized management. That again reflects the decentralization. Cryptography and computer code strengthens, collaborates, and between organization and individual to form a global network. And the applications can help move intermediates from existing process. Okay. With that, I want to show you how the mining works. So this is typically what I've shown you from a chip all the way to a node to a data center, how the mining can operate. Okay. So basically mining is a process to validate every step in a transaction while operating a Bitcoin or any other cryptocurrency. Now I'm just lifting myself one step higher and talking about Bitcoin. Now in Bitcoin, this is what is happening because I need to reference Bitcoin for the mining example. Now, when I say mining, what happens is each node have to do a validation of an incoming transaction. Now that is termed as basically mining. Now mining takes a lot of computations because each node has to do the same verification and then say validate. It's not like one central authority is going to validate, hey, it's a valid transaction. No, each node has to do it. Each node has to nominate, and then the consensus comes, then only it is accepted. That makes it resilient. That's the beauty of blockchain mining actually. So mining is a distributed computational review process, which is performed on a block of a data in a blockchain, and it consumes a lot of computing power, but the results are you have a very solid hacker-proof or foolproof validation. I can't say hacker-proof, but still it is a foolproof validation. Accomplishment of consensus where neither party knows or trusts each other. They don't have to trust each other, but just have to validate from each perspective because each of them have to nominate. Okay. Now, what I've shown you is a typical chip which can do the same hashing algorithm. And I have also shown you a compute node. It's a server. It is much powerful than a normal x86 which you're running your laptop. And it can churn out 56 trillion hashes per second. In spite of that, that one single node might take years to do a mining process. So you need cluster of those nodes like what you see in the picture to do the actual mining. Okay. Let me go back. Okay, now you understood a mining part, right? Now, these are the elements which basically builds the blockchain. Now, what is the beauty of blockchain compared to internet? You don't have this verification and solid way of crypto links. All these things fortifies blockchain better than internet. Okay. moving to the, oh, before that, I just want to ask you, any questions here so far?
So what do you mean resilient? Resilient.
Yeah, resilient, it can, when even in, there is no, basically failure proof, I can say. Even one node fails, the rest of the nodes will take care of itself in the consents. That's what, it is always alive.
Oh, okay, sir.
Any other questions? Okay, if not, let me move on to the next page. So there are different types of blockchain. Srinivas brought it up. I just want to reiterate again. There's a public blockchain. I think Bitcoin, Ethereum, they're all coming from the public blockchain side. It's created by open source computing nodes. And then private blockchain, where Hyperledger, Ripple, most of the finance related blockchain networks are based on this one, or even organizations. They go after a Hyperledger, they go after private blockchains. And hybrid blockchains, the one which will have the benefit of both public and private. So I'll bring up some examples where you want to see that. So some organizations want to be private, at the same time they want to connect to a public blockchain. So they are given this benefit of having hybrid. They exist in a private, but then the final result will get into a public blockchain. So that is about hybrid blockchain. And then we have this federated or consortium blockchain, which is coming up right now, which is a consortium of companies, larger organizations, or any major network of organization can come together and they form a consortium. The recent example would be Ethereum Alliance, Enterprise Ethereum Alliance, WEA. It includes members such as Microsoft, Accenture, JP Morgan, and Wipro Technology Corporation. All those basically form the EEA. Okay, now this consortium looks like private. However, since it's multiple organizations, they would have the privilege of getting into a public as well, if they want. So, but they still keep it as a consortium where the standards, as when you get into the contracts, smart contracts, will be uniform. Okay, that's the idea. Now let me click on to the type of blockchains.
Hari sir, we are not able to hear. We are able to see the video, not able to hear.
Oh, okay. I think most of the content doesn't have voice. It is just music. I hope it's okay.
Okay, no issues.
Yeah, I think we just run over the types of blockchain in a more descriptive way. That's what it is. Before I step inside the Bitcoin, you have any questions on the types of blockchain?
Actually, sir, blockchain means is whether all the computers are connected. So, how can understand, sir? Blockchain in the sense already before internet we have.
Visually, if you have to represent, yes, physically it's a connection of nodes, which is nothing but a computer which has a x86 chip or probably any other form of computing element. That's how it is work. Now, that's the difference I brought initially between internet and blockchain, right? When you have certain way of securing the same network by following the blockchain protocols, then you create a blockchain network actually. You can see below the matrix here where a system is connected to a mobile to a, so typically this is a blockchain network.
Okay, sir. Actually, the VPN virtual private network like this blockchain also one kind of network or output I can understand.
Yeah, so VPN is on a private network. It creates multiple protected sockets within a IP channel, and it can have its own sockets end to end. Okay. Now, blockchain is much more than that. And sorry, was there a question?
No. This is some.
Yeah.
Participants, please unmute your, please mute your mics.
Let me know if I have to start.
Yeah, you can go ahead, sir. You can go ahead.
Yeah. So blockchain is much more intelligent than VPN. It gives you a much more well-established synchronization. In fact, VPN needs a server versus multiple clients. There in between, it gives a network channel where your virtual channel is protected, right? Now, this offers a network by itself where you can see a lot of other applications at application layer level. You will see much more benefits in blockchain. So just don't think about physical layer, go much above. That is where blockchain is going to support you.
Okay,
Did I answer your question, sir?
No, sir, you go ahead.
Okay, so you can see here the number of blocks. Each block has got a transaction element. It just goes in blocks. I think Srinivas explained this in the morning. They are chained with hashes. Each hash has got unique code. You can see here. Now, this is how your information is moving in blockchain. Okay, just an analogy here. Okay, let me go into the Bitcoin. Now, Bitcoin is basically a application which uses blockchain. Now I'm going to cover the later part about much more application. That's the reason I want you to understand what is Bitcoin. It's a chained, interconnect, cryptographically secured block containing timestamp transaction details. I think, I mean, each of the Bitcoins today are represented to the actual money. At least there is an ownership for the actual money in every country. For example, in India, it's RBI, which acts as a broker, who also manages that thing. But in Bitcoin, it just comes out of a thin air. It just the consensus algorithm, the blockchain, and also the hash algorithm, and above which what the application runs is determining everything. So all the nodes come together and say, hey, yes, it's a valid Bitcoin. That's how it works in Bitcoin. So always there is a struggle in both worlds, but however, we have enough participation on the other side as well. So we have to know what it is. So let us know that and see how it can benefit us in other applications. Okay, now you can see that each block the transactions are happening. There's a block header, there's a hash for the previous block, like your typical TCP/IP packet, which carries the start and end. It has a hash algorithm which represents the previous block header. And there's a Merkle root, which is basically carrying the block transactions. So each of these blocks move, and that's how your Bitcoin is transacted. So you can see what is a block here. It's I think there's a transaction example also. Alice sends Bob 5 coins and Bob sends Charlie 3 coins and Charlie sends D 2 coins. This is basically the transactions which is happening. I'm just talking from Bitcoin example. Then you have this Merkle tree, which basically gives, it's a tree actually. It is how your basic consensus is derived. And you can also see the previous block representation, and every time the block hash is going to be unique. Now that is a random number generated at each point, and that makes it crypto-wise stronger and much more stronger than your actual money, right? So that's why they call it cryptocurrency. I want you to understand this concept. Okay. Let me move on. Okay, now you can see how it works. So basically the miners, I told you how the mining happens, right? The miners creates the Bitcoin. There could be multiple computers who are working on it, and then basically the exchange or trade agents, which are basically handling the conventional currencies and Bitcoins, they do participate in it for cashing out if needed. And then you have other stakeholders, like you can download in a commercial application. For example, you have an account in some e-trading. You can create a wallet and have a Bitcoin there. I think many of the companies are offering now to have a wallet and have a Bitcoin instead of the actual money. And then with the wallet, you can have your transaction executed. And typically, if you open a click of Bitcoin, this is how it looks. What you see to your right. I think 112 US dollars is represented there, like 477.06. I think so. Below that, you can see the transactions, right? That is the number of thing it has traveled basically. So you can see from 15th April, 17th April, and then all the way 20th, 21st April, how it has really moved along. And each of the time it will carry its own value also, because it's a trade. Because of the trade, it will start increasing. The value starts increasing. Okay, this is an end-to-end transaction, starting from different blocks all the way until I mean, at each point, say, let's say how the chain looks, or the interacting with basically a application provider. It's basically end-to-end. It just shows. Okay, so let me move on. Okay. Now, having learned about the types of blockchain and the Bitcoin as one of the applications or examples, how it was using blockchain. Now, we have to see what are the decentralized versus centralized application. I talked to you about internet. I talked to you about blockchain. Now, you want to see a real comparison, how it looks. This is how it looks. You can see Chrome, a centralized version, which is basically running on internet today. And you can see the decentralized version, which is running on blockchain. It's called Brave. And Google Drive, we have Storj, which is operating on blockchain. Google, it is equivalent to a Google Drive. And Skype is live here. And you can see the OS, Essential One and Brahma OS, it's a blockchain OS. And Facebook, and you have enough applications there actually. WhatsApp, you have Signal. Signal runs on blockchain. And then PayPal, and then we have Ripple. So accordingly, you can see starting from a browser all the way till payment, how the blockchain equivalent of internet applications have evolved. I think these are all functional now. There is no doubt it's already functional and people are using it. Any questions here? Okay. Let me move on to the. So far, you are able to understand, right? How what is blockchain and what are the impact on its on our current internet, how it has evolved. Okay, that's the only thing I want you to know. That's for now. Okay, now this is a platform of blockchain by IBM. Now, typically, I talked about private blockchains or even hybrid, right? Now, this is one example where the Hyperledger platform from IBM is offering a blockchain. Now, you can sign up with IBM on this one and then use this platform and start building your applications on blockchain. Okay, that's the intent. So you can see it is built on IBM Cloud, and then we have a Hyperledger Fabric on top, and then we have a deployment framework that is cloud basically, and also a development framework on top of the Fabric itself. I just want you to see how it is there. And so if you see the Fabric, it's a blockchain network service. All the blockchain network services offered there in the Fabric. And you can build any application like the one I showed you in the earlier one. Like that, you can build any kind of applications. Today, it's already being used, and many companies are using it to build their own applications. So on the Composer side, it provides a convenient layer like business level abstractions, create a blockchain network, implement a smart contract, and deploy them in the Fabric. Now, smart contract is one more thing I want you to understand. Just spend some time there. Okay. Now, typically a transaction happens. I mean, imagine our RBI in the middle. There's a selling house, there's a buying house, and we have RBI in the middle who facilitates. Now, removing RBI, I'm going to put a digital ledger there and an algorithm there. Now, what happens here is that algorithm or a piece of code which is running there is going to be your deciding authority, which is there's no people or any human thing there. It is completely automated, completely digital. Every time, whatever you do is going to record in a ledger, and that is a smart contract, basically. It could be very simple code. If I have to open a smart contract and say, sometimes it will be a very simple if then else statement, mostly. Otherwise, now I see AIs are coming inside. They keep it as small as possible or as minimal lightweight as possible, because it should not consume more resource by itself, because each of the nodes are consuming more resource by validating, right? So smart contracts are very, very lightweight. It's an algorithm, basically. It's a piece of software which is running there. Now that is smart contract. I just want you to understand that. It can go to any level of complexity, but for now it is very, very simple. Okay. Now this is how smart contracts work. Okay. Going back now, you can use this IBM platform for building your smart contract also. Okay. Now, further expanding. I told you about the blockchain as a service. I mean, one of the layer was offering as a service, right? So what is prerequisite? They are basically looking at for scalability, high availability, disaster recovery, secure access, single sign-on, ability to conduct private transactions over secure channels. All those things are prerequisites for this. I mean, meaning it's available. Organizations which support these blockchain as services are starting with Huawei. Huawei is offering secured and encrypted peer-to-peer network, pluggable consensus algorithm, smart contract functionality, and secure cloud services. And IBM, I just showed you the Linux One block service right now in the previous page. So that's from IBM. Amazon is also offering blockchain as service, that is BaaS. And in their component wise, I think morning Srinivas was showing it in a picture. So, and then Microsoft Azure is also offering blockchain as service. Then Oracle. These are standard industry giants who have already moved into this one, and there are many applications already built. You can also build the application using these services, and very easy to connect also. But you should have a solid application, because most of them are commercial. For academic, there are some opportunities, but mostly currently commercial applications are running. But Microsoft as well as Amazon are offering a 1-year a free service where you can explore these blockchain components. Okay, so any questions so far?
Sir, actually using this blockchain as a service, that is whether it's from Oracle or from Amazon, whether we can add bitcoins, we can
Yes.
sell the bitcoins.
Yes, we can. You can create a node using any of these services, and you will be nominated for. I mean, you need to nominate to the Bitcoin thing, and then once they have the recognition done, you will be one of the nodes appear rather, and the mining will happen on your compute element, for meaning the validation of any transactions will happen. Yes. In simple words, you're offering the infrastructure for Bitcoin. That's all.
Oh, okay. Thank you.
Yeah. Any other questions?
Sir,
I basically want everyone to think about this, because this is going to be the next, or rather the current engagement. It's already happening in each of your neighborhoods. And you need to know this before you start paying in Bitcoin, right? It will automatically come, and one day we'll all be paying in some form of cryptocurrencies. So, and that is already happening. So please be aware of it.
Sir, may I have a question, sir?
Yes, please. Yeah.
Sir, what is actually happening on the process of mining, sir?
Yeah. So mining is basically generating hashing and validating. There's a lot of random numbers generated for hashes. That is basically processing. And also in simple English, if I have to say, it is saying, yes, I have validated this new transaction which has come. So here is my contribution to the consensus algorithm. For example, if I have 100 nodes and I'm running a Bitcoin transaction there, all the 100 nodes are expected to fall into the consensus algorithm. Now, how do they fall? They have to do their own processing, right? Now, that is what is mining. They will go and mine that particular transaction and validate it, and then say that, yes, it's a valid transaction.
Thank you, sir.
Yeah. Any other questions?
Sir, actually, that mining, anyone can be the miner, or any kind of selection, or how one can be a miner?
Yeah. So as I told you, so first of all, you need to have the infrastructure for it. Then there is a nomination process. So you have to be part of that nomination. Then you also will be recognized as a node and a peer. Like, for example, if you want the internet connection at your home, right, you need to have a basic KYC process, right? Like that, there is something for Bitcoin also.
Oh, okay.
You got it? Okay. Any other questions? Okay. So I hope all of you are clear about blockchain now. Now with that, let me go into the practical aspect I'm talking about. Let me go into big data now. Okay, again, Srinivas has given enough insight on big data. I'm just going to cover as much of practical examples as possible. Please interrupt me if you have questions. Now, big data, I mean, the data which is too large to handle. It is not just your firewall sitting at your lab, which you can handle big data. No, that's not possible. Typically, they give an example about 1 petabyte, that's 10 power 12, that's 1 petabyte with traditional methods. And we will be, so how do you process that kind of data? That is where the big data has to be recognized, identified, and then how do you process is the next question. So examples, predictive inventory ordering, personalized marketing, streamlined media streaming, personalized health plans, live roadmap for autonomous vehicles. Now, the fact that we were in early stage of internet handling data, and each of the clusters you saw, how much it has grown worldwide, that basically opened up this technology. How do you process such large volumes? And it has got significant parameters. You need to identify that, right? So that is where volume will come, velocity will come, veracity will come, variety will come. So volume refers to quality of data, as I told you, and speed of data refers to the velocity, and quality of data refers to the veracity, and variety is the types of data like structured, unstructured, semi-structured. We'll cover what it is all about. Okay, Now, I talked about big data, giving you a visual feel of what it is. Typical social media is 12 plus terabytes of tweets every day. I think this is still 5 years back old data, but still I'm saying British Library in the UK website, it is handling 110 terabytes per domain to be delivered, event crawl to be delivered. And the LHC, Large Hadron Collider, the CERN, which basically looks into our cosmic data, it's 90 petabytes per year, 10 power 15. Internet communication as per Cisco is 278 exabytes per month in 2021. I think it's going to increase more. Digital universe, 44 zettabytes, that's 10 power 21 at the dawn of 2020. Now it will be even more. Okay, so with that, I'm going to show a small video on IBM's big data, how it works. Pardon me if you don't get voice, I can still help you to understand, but I want you to look through it. Okay, just wanted to give you an insight, and I hope all of you understand now what is big data and about it, and how much it is serving the current industry. Okay, moving to the types of big data. Structure, which could include your basic address, age, contact addresses, all those kind of data, which is more structured, is referred under structured data. Unstructured examples would be image files, audio files, log files, video files are unstructured. Semi-structured, which is personal data stored in an XML file, or data containing both formats referred over. All those things, unstructured and structured. So these are semi-structured. And also the subtypes of data, which basically the social media, geospatial, event triggered. Those are subtypes of data which comes in under big data category. Now, all these have heavyweight applications. Today, we are using it actually in many forms. That's the reason this highlight is essential. Okay, any questions here? Okay, not. This is a example of a big data platform. It's basically using the Hadoop platform management. Hadoop as technologies basically, and it's a platform, so it has a layer, the monitoring layer, security layer, and a management layer, visualization, and also how do you handle different types of data sources is what you see there, and then intersected by the data classification. And there is an analytics engine, which basically do a text analytics, real-time engine, and then a statistical analysis also. And different kinds of Hadoop software or OS and components which drive, starting from MapReduce, Pig, Hive, Scoop, Zookeeper. All those things are applications to basically get the data to your visualization layer. Giving one simple insight on the Hadoop itself. So you can see the data storage, basically it's happening in a HDFS system. And then we have data processing. That's where your MapReduce and Yarn come into place. And then we have the data access. This is where Hive and Pig or Avro or Scoop come into place. And then data management finally, where you have Zookeeper or Uzi. All those things will be used. Now, each of these software applications are needed. As I told you, in a typical RDBMS or a database, any kind of database, You still live with your own systems with a normal x86, and then handling the data. You can live with that any kind of database software, and then finally have a firewall connected to a network. That doesn't work here because you have, as I told you, the size of data is huge, and there is a lot of attribute to it: volume, variety, veracity. Now, how do you really classify these things, right? And if it's real time, it's even more challenging. That is where these applications really are useful. So when I showed you a platform from IBM, that's Hadoop platform, you see all these layers are at different levels. So when IBM offers big data processing as a service, they will give that as a complete infrastructure, and you can plug it into your big data applications and maybe process that end product into a different services or service applications, allow that data to go into a service application and have it available. I can just simply tell you that an example would be LinkedIn. LinkedIn has got so many customers worldwide, right? Today they are handling a big data and then also blockchain. So the big data is what our data is going in different forms, and then it is classified, aggregated, and then getting into a meaningful format. And later the knowledge management and trust part is taken care of by blockchain. Later, how it's all processed. So LinkedIn is one good example. But I'll still cover the use cases later. I just want to give you an example here. That's why I wanted to show this. Okay. Okay. Now, given that, still there are challenges handling big data as is. So what are the challenges? Like data security and privacy issues. So the quantity of data stored in third-party locations, cloud, is actually increasing rapidly. That poses data breaches or threats. Every organization has got this issues. So now traditional firewalls will not help. So that is where this is one of the identified challenge. Then comes dirty data. What if the data itself is erroneous? How do you pick the needle from a haystack, right? It's going to be a challenging one. So dirty data you have to handle. Reliability of data source. Main challenge associated with big data is quality of data. I think you can link it to the dirty data also, but reliability of data matters in a healthcare application, right? So there, your big data is of no use if your reliability is not good, right? So that is the problem. And sharing of data. So now today there is a network like intra-institutional documents have to be shared, right? Everything has to go. Blockchain works in that way. So many of the transactions are shared, right? Now, how do you make sure without a breach, without any erroneous things? How do you handle it? Will you go and expect every public institution to follow a protocol so that the data is so perfect while sharing? We don't know. So that is big data problem. We have identified an ocean of data. Now and we have to find a way how to secure it, how to make it improved with quality, how to trust it, how to make it more reliable. Now that is where blockchain comes into place. Okay. Now the actual scenario comes like the need of a trust-based framework. That is where blockchain is offering. I will just cover that shortly. Okay, any questions till now? Yeah, I'm just going to pause for a couple of minutes for you to think through. If you have any questions, please read it out in the chat box. There's a lot of data to consume, a lot of information to consume. I want you to start visualizing in your own way. How do you do that in your typical lifestyle? So, or you may be already doing it and you may not know. Now you can visualize better. Hey, the WhatsApp I'm using every day, is it part of big data, right? It's a valid question. I say yes, it's already part of big data. So now then, is it WhatsApp is using blockchain? Maybe, we don't know. maybe Twitter is using, so why not WhatsApp? Facebook is using. Okay, any questions? If not, let's move on to the transformation. Okay. Yeah, just an analogy how the systems of systems and your PCs to your mobiles to your thing, how it is basically interlinking, and finally blockchains, once it's connected, how it's adding value to big data. Let me move on. When you integrate, these are the things which are coming as a benefactor. Improving big data security and privacy. I think we talked about it. Now, blockchains basically stores big data and avoids challenges such as data breaches, threats, basically the decentralized storage of data on the blockchain network makes it very difficult for any unauthorized access. Next is improving data integrity. The immutability property ensures that it is next to impossible to tamper the data stored in the blockchain network. Because it's based on the chain logic, the number of nodes logic, the consensus algorithm logic. Remember, we talked about consensus algorithm. If 99 guys says yes only, then that becomes a valid thing. Imagine a hacker creating a duplicate data. Only one node will say, the rest will all be sidelined. So that node will fail, or the 99 will be nominated for good. So we have identified the culprit where that makes it, more. I mean, it's basically covering the immutability property. And also, you can see the breach of data it's next to impossible. I'm not saying it's impossible, but it's next to impossible. The reason is a lot of cost and a lot of infrastructure is needed. For example, a nation can do a blockchain hacking, or large organizations can do, which easily will get identified. So, the kind of investment on doing something wrong is huge. So they won't, it won't happen literally. So that's all about it. And fraud prevention, I think I explained it while. It's basically the financial institutions, for financial institutions, blockchain enables the real-time data, allowing to access potential fraudulent transaction, like the way I told you. And also it's more proactive than reactive. And the real-time data analytics, it stores every transaction, makes the real-time analytics, big data achievable. Enhancement of data sharing. Service provider benefits from sharing of data to other stakeholders with minimal risk of data leakage. And blockchains recording prevents repetition analysis on data. Yeah, true. Because it's going to be recorded, and you're going to see if something is happening again, you will know it's a repetitive data. It won't happen also. So enhancement of quality of big data. The structured and complete feature of blockchain ensures improvement in quality of data. So these are the attributes or benefactors when you integrate blockchain with big data. Any questions? Okay. Yep. And these are the different technologies right now. We can see there are many, starting from AI to Internet of Things, robotics, machine learning, big data. The blockchain is integrating. I think today's focus will be on big data. However, I want you to know that there are other domains also integrating and working along. Today, in a typical organization who offers infrastructure as service, they don't restrict it to just one technology. They give you everything you can choose from. If you walk into AWS and probably sign off EC node, and then start building your application in any form, starting maybe a portal or a website for your academic thing, or even a project. Now you'll be given options to plug into a different modules, different systems, which offers different technologies, starting from AI to IoT to robotics. Everything is available now as a service. So blockchain is basically linking to all these elements because of its benefactor and the trust which it can add value to each of these technologies. Okay, even this has challenges. I want you to be aware of it, but these are expensive challenges. It's not that easy, but still I wanted to highlight basically security and privacy enhancements in big data. That is one of the challenge. And when you get into cryptocurrency, big data or smart contracts, there is some vulnerability scanning, programming correctness of security correctness in smart contract that could be exposed. That could lead. What if it's intentionally a bad contract? Of course, it will be exposed. It's not that it won't be, but still it's a vulnerability. Just want to mention it. And Internet of Things, big data, blockchain, fog computing. In that, we have the big data security is in fog enabled IoT using blockchain. That is also because the edge IoT node is prone for attacks. However, it will be isolated, but it's prone for attacks. So that's why I want to classify that under security. E-crime detection, Bitcoin price predictions. In that category, interpretation of data stored in public blockchain is kind of breaching, but it is recoverable. As I told you, it's resilient, but still, it is doable. Then the smart toy assisted with mobile edge computing and blockchain, and the smart contracts again, validating various data exchanges. There's also a security and privacy challenge. Crime and big data, mining of data using various state-of-art data mining techniques. Yeah, we do have opens there. Some complexity is could be higher. Big data and mobile network optimization explores features of big data from perspective of users and network operators. Now, each of these are not, so when I call data, it's just not one, it's coming from one single element, right? It's going to be clusters, it could be vendors, it could be organizations, it could be third parties. So many people are involved. Now, that's the complexity part. I wanted to understand that way. Though the parameters of big data ensures that variety, volume, all this categorization and blockchain builds the trust on top of it, still you have to live through all this thing. That's the complexity part. Cyber physical social systems, and this is on the computational overhead category, which is a challenge again. And the distributed database again. Each time, one of the challenges in blockchain is higher computation. I mean, it comes with a cost, and what is the cost? Higher computation. As simple as that. You want trust, you pay for the computation. As simple as that. So larger applications benefit out of it. When you write small businesses, it may not. However, blockchain as a service, when you bring it, when your number of customers increase, you can see this as a value add. Okay. Any questions till now? If you want to type in the chat, please type it, but I request any one of you to read it. Okay, not, let's move on. I just received an annotation request. Should I approve it? Okay. Next is tools. Oh, sorry. So you can see here the different, sorry. Yeah, I hope all of you can see it. There are different organizations who are offering big data processing for blockchain. I just wanted to bring out the tools which could support you. So just wanted to highlight the organization which are offering first, then we step inside the actual tools offered by organizations. Storage, I think I showed you initially from the examples on open internet versus blockchain. This is one of the companies which offers a decentralized file storage, something like your Google Drive. That's what they do, but on a blockchain framework. And then Omnilytics. This is basically combines blockchain and data analytics it uses AI and machine learning, part of the analytics. It could be used in marketing, financial analytics, auditing, trend forecasting. So it offers all these services based on the data. And then Datum. Datum is a decentralized storage network driven by DAT. Now, what is significant about Datum is while the big corporations are driving you to engage in certain form of data, this offers more of democratized or rather most personalized storage for each one of us to go and use. But it runs on a blockchain network. Blockchain ensures that the data is securely stored and no breaches. So Datum liberates the private organization's way of thinking, and then it gives more on the customer side. It gives more benefits. And then Provenance. Provenance aims to use blockchain to build trust in the journey of a product and basically the product management lifecycle. And it also brings to understand the impact of environment and better product tracking, empowering customer with new information. That's Provenance, but it has a tracking mechanism where applications can be made from end to end. It could be asset tracking or all the way from the vendor distribution to a complete product launch. You can use Provenance for it. Okay, those are the organizations. Any questions here? Okay, now as I told you, AWS, right? Amazon Web Services, they're offering blockchain solutions. So EC2 nodes, anybody can create a EC2 node. They give one year free. So I encourage each of the students to go and create the EC2 nodes and start using that instead of your actual laptop and waste the x86 cycles, CPU cycles. Use EC2 nodes for 1 year, build your program and play with it. So I encourage, that's more from education point of view, but for the blockchain as such, AWS does offer solutions, and this is how it looks. You can see multiple end users starting from healthcare, labs, clinics, and we have a framework for blockchain in Amazon, and that is connected in different formats, say starting from DynamoDB for NoSQL, Redshift for data warehouse, and Amazon's simple storage services. You can have storages and Kinesis data streams. This can be plugged into a third-party like Hadoop, right? A third-party big data infra. So that you can take this entire piece and plug it into a third-party big data infra. So that way you will have the data coming in. Like for example, you can use Amazon Kinesis to stream the big data and then process it in blockchain solutions offered by Amazon. One of the tools. Okay. Yeah, before I go to applications and use cases, so far, I think you have understood big data, you have understood blockchain, you've seen how it can integrate, and you saw a small example of tools also. Till now, any questions? I'm going to pause for 2 minutes. Just tell me if you have any questions before I step into applications. For any one of you who want to chat or type the question in the chat, please type it. But I want one of the faculty to read it because I can't see the chat here.
No chat messages, sir. No chat messages.
Okay, then let me move on to the applications.
Sir, one question from audience.
Yes, sir, please.
Sir, could you please explain Amazon EC2 Tier 1 or Tier 1?
Yeah, so
Amazon-
EC2 is nothing but an instance. Imagine your basic laptop or a computer, no, right, in terminal in your lab. The same thing Amazon is offering via their services through web. So if you open a browser and go into Amazon portal, AWS, you can directly go. You can sign up like your any other Gmail or Hotmail service, or any other service, mail services. It will be asking. Once you qualify, they will send you, and you can nominate which one you want, which infra you want. So if you can, basically first you start with EC2. EC2 will, once you click on the EC2, it will give you a console. You can click it and you can see a console opening in your, as if you're running a virtual console in your own laptop. If you run Ubuntu on your laptop, what happens, right? On top of Windows, that's how it will come. Or rather open a DOS window. So that's how your EC2 instance will also come. Now that itself is your laptop, is your, you can build applications on top of it. What they give is a basic hardware and an OS and an application on top. And then you can start building whatever you want using that. At most of the students in US universities, and they use heavily Amazon services. I mean, the first trials site I'm saying, because you can log into any console or any terminal starting from anywhere in a browsing center versus your home or in your guest house or anywhere. You can open it and then start doing your work, continue your work. So you should start using it, and then you will be off. You will, that's the first level. And then once you get through that, you will get to know the next level. What and all you can add. Do you want more storage? Do you want more CPU memory? Do you want more RAM? You can add actually. And later you want, what do you say? You want to process some IoT streaming? Do you want IoT module itself? Yeah, you can do that. So I think there are enough YouTube videos on that. I don't want to elaborate that, but you can start first, start playing with it first. It's okay. It's okay to do something wrong in this area because you have to know it. So first you attempt it, do it, then you will see you start leveraging you start loving the CPU cycles more than your fuel to your vehicle. You will start respecting the CPU cycles. I think every I mean, code developer who is in the high-end side launching apps, they know the value of CPU cycles. Okay, any other question? Okay, if not, let's move on to the applications and use cases. Yeah, so here we have the blockchain big data applications, starting with smart city. I told you about the hash algorithm, the asymmetric encryption consensus algorithm, and the Merkle tree. So it's basically tamper free because it's very unique. It's using a crypto link. So because it's a very unique hash, so you won't get it anywhere. That's the reason it is crypto friendly, or rather hacker proof. So tamper-free transaction in IoT device, development of decentralized, secure, auditable environment for IoT device. So that's one of the applications in smart city. The smart city is, I mean, you have different physical, non-physical assets, right? So imagine each of them are tagged and they form into a blockchain network. How much worthy it is, right? To trust something, right? You will be, I mean, the data is not a dirty data. You will start qualifying it using blockchain more trustworthy. And it'll be, and each of those, the moment it is trustworthy, you can build services on top of it, right? I mean, what if your everyday news portal is sending bad news, right? You don't want to see that, right? The reason you're prompted to go and click that button in your news, or rather your messages, is because you feel that news is credible. That's the kind of value add you get on a building blockchain in a, or processing the big data with integrated with blockchain in a smart city, starting from your electricity or your sewage or the public infrastructure or disaster management. I think Srinivas got very good examples in the morning as well. So all those things are more processable, and they can take it to the next level, right? The predictive analytics, you can take it to the next level. There's a lot of value add. That's where we see a huge potential in smart city applications. And then smart healthcare. I don't have to say this. There is enough reasons why your data has to be perfect, trustworthy, and I mean, proof of, I mean, it should be so valid that it is hacker proof. So all those things need some framework which offers that stability, right? So that is one of the very big use case is in smart healthcare. I think already organizations are getting into it. I'm sorry, using it. In fact, we are. You wouldn't know that you are also part of that as a customer. So just probe it and see. I don't want to say, but just probe it and see. It'll be part of your life. Smart transportation. Yeah. This is asset tracking, like it's track and trace, fast payments, starting with your Ola, Uber, everything is already in this network already. It can track at every level. So I'm just talking the consumer side of it, but there's also enterprise side where the logistics is huge. That is also tracked. Smart grid energy management. This is also a big topic, and blockchain plays a huge importance here. The P2P energy trading, peer-to-peer energy trading, a lot of innovations are expected there to come in. It's already in countries like Germany, this is full time. I think in India also it is going, it's already happening, and it has happened in certain part of the country. So this is also one potential area where big data and blockchain integration plays a huge role. Yep, this is a typical case of Walmart, and Walmart Retail has implemented this blockchain for their retail. This is again the chain of outlets in US, so it's a larger data to process. You can see the way that it's run, why, what, how, and what are the results. The maximize customer service. They want to maximize customer service just to have the competition. Yeah, and what do they use? They say data cafe for real-time analysis. And you can see Hadoop, Cassandra, Spark, R, SAS for storage, processing, analysis, and presentation. All these are used. I think we run over the IBM platform, right? Something like that. They've used it here also. And they manage data from 200 billion rows of transactional data and 200 external source of, leading to a cycle time reduction of 3 weeks to 20 minutes. That's huge, actually. So let me give you a snapshot. If the voice is not coming, let me know. I'll stop it, because this is basically an interview about Walmart, how they use blockchain.
Hari sir, Dhanantar, you can say what they are trying to discuss because we are not able to hear audio.
Okay. Then it's no point. Hold on. Yeah, the same thing which I explained in the table. They are just discussing. What they're discussing mainly is how does blockchain is influencing, or how does Walmart use blockchain to track their inventory system. I think the interviewer is asking the lady who's the CEO of offering this service and using blockchain, and how they are tracking each piece sold out of Walmart using blockchain. And she's just giving an insight from a traditional barcode mechanism, how they have graduated to a blockchain level system. And barcode can also be a subset there. And but blockchain brings the efficiency overall to the system. So that's what she was explaining. Okay, so let me move on to the next one. This is again a video, but I think I may have it in a different format. But if the sound is not coming, I'm not going to play it. But I just want to explain what is NFT. NFT is a new terminology, but it's been already popular. It is coming in similar to Bitcoin, I would say. So this also is done with a blockchain framework. So NFT is unique and non-interchangeable unit of data stored in a digital ledger. Now, it is easily reproducible, such as photos, videos, audio, everything. And today in the art world, NFT is huge. I can just show you what it is. And I'm just giving you a high-level example. It is basically, it's not a cryptocurrency in which one Bitcoin is equal to another Bitcoin. It's not like that, but it is another a digital way of representing an asset. Okay, and they are using today predominantly, what is famous is art. Every art available, the art industry basically. So they trade their art using NFT. And art can be converted into related to NFT token, and then it has a value now, and then now it can be traded. There are companies already formed and they are doing it already, but it's a huge market. It has already started. Just wanted to let you know. And hold on, this video may not have audio, then it's no point showing it. But I'll try once. If you say no audio, then let me know. I will stop it. Are you getting the audio?
Actually, audio we are not able to get, sir. Actually, here you have to go for sharing, then you have to give the optimize the that one.
I did do that. Hold on, let me try it one more time.
Yes, sir.
So I may have to log in and log out, right? That's
No. Just click stop sharing.
okay. Fine.
Yeah, just stop sharing. Yeah, now click the share button. At the top, you will find optimize video audio.
Yeah, I got it.
Yeah, fine.
You getting it?
Yeah, now you can play, sir. Yeah. It's coming, sir.
NFTs are not a scam.
Coming.
Oh, good.
NFTs are not a fad. In fact, NFTs are the building blocks of the internet of the future. But in order for us to see this future clearly, we first need to go back into the past. The year is 1992. The World Wide Web is only 3 years old. This is what it looks like. For the first time in human history, we share a global commons, where irrespective of where we are in the physical world, we can convene and share information freely. Most people at that time couldn't see what it meant to be connected by a network of computers. In fact, many people thought the internet itself was a scam or a fad. But a few early internet pioneers saw the potential in this burgeoning technology. One of those early internet pioneers, John Perry Barlow, saw both the opportunities and pitfalls inherent in our new digital world. And of early cyberspace, he posed a prescient riddle all the way back in 1992 that I'll paraphrase for you. If our property can be infinitely reproduced and instantaneously distributed across the planet without cost, how are we going to protect it? How are we going to get paid for the work we do with our minds? And if we can't get paid, what will assure the continued creation and distribution of such work? A lot has changed on the internet since 1992. The internet itself is an alive and evolving technology. And as predicted by its earliest champions, the internet has increasingly become our default context. Today, one's job, wealth, relationships, sense of self are all often more mediated through our digital contexts than our physical ones. Yet Barlow's riddle has remained vexingly unsolved. Concepts like property and ownership, ideas that have been with us for centuries in the physical world, have evaded us in our digital spaces. We've tried to voice copyright, DMCA, DRM, and watermarks onto the internet to protect our ideas and to restrain their distribution. None of these approaches have worked. Why? Because as Stuart Brand, another early internet pioneer, famously coined, information wants to be free. It wants to travel effortlessly, without hindrance, without encumbrance. This is what allowed the internet to succeed in the first place. Since 1992, we've uploaded trillions of photos and videos and even cat memes to the internet for free. And what business model has allowed this information to be free? Advertising. Advertising is the internet's default business model, not because that's what we want, but because it's what pays the bills. Right now, the few large corporations that run the most effective ad networks control most of the value on today's internet, not the people creating its content. On today's internet, we don't get paid for the work we do with our minds. And what's more, the content we upload to these services is trapped there. These services not only make money from our content, they control it. Until NFTs. NFTs are a technological breakthrough. They offer us the opportunity to break away from that broken system. So you're asking yourself, what is an NFT? It's a certificate of ownership registered on the blockchain for everyone to see. It's not too dissimilar to the deed you get when you buy a house in the physical world. But instead of a house, an NFT denotes ownership of a file on the internet. And unlike copyright or watermarks, which are ancient technologies rooted in bygone eras, NFTs are internet native. They are born of the internet for the internet. And NFTs don't simply port our existing model of ownership from the physical world, they improve it. In the physical world, ownership actually fences people out. It precludes others from enjoying what you own. I wouldn't expect to feel welcome in your home uninvited. Digital space, however, is expansive. It's home to the infinite, the exponential, the instantaneous. NFTs offer a system of ownership that reflects this expansiveness. With NFTs, my owning something doesn't preclude others from enjoying it. In fact, it's the opposite. The more an NFT is seen, appreciated, and understood, the more possibility it has to increase in value. Let's take an example. Neon Cat, a wildly popular, instantly recognizable cat meme.
Yeah, I just want you to know about it. So I think that should be good enough. Now you got the concept of what is NFT, right? So this is one of the rising, or it's more popular like Bitcoin. So it's coming up already. A lot of major organizations are investing in this one. Okay, so a typical JPEG, what happens if you want to have a ownership, you trade it using NFT. Basically, how do you do this? Create digital art into an NFT. Just set up a MetaMask, it's nothing but a crypto wallet, and get connected to numerous blockchain applications, get into a store, and then go into a marketplace, make your collection and sell your NFT. That's it, done. Your art is sold for a NFT, and that is equivalent to some form of currency. That's it. Okay, this is from one artist, so just wanted to let you know. Okay, now companies like OpenSea do these heavily today, and many of the arts around the globe are getting traded. You can see the NFT sales in May 21. It has skyrocketed like 100 million USD. It has gone, and the wallets are also equally flooding. There are more than 5,000 active wallets already. So this is already happening, and I'm not restricting it to art. I may show this example for art. It's not just NFT is not just for art. Any form of document, video, anything you do, it can be made into an NFT. Sorry, was there a question?
No, you go
Okay.
ahead, sir, go ahead.
But the foundation is blockchain. I just want you to know. And who plays this? There's a heavy big data also here. And there is a big data processing system which operates it, classifies it, makes it better for the end user to go and pick and then buy it. So all these are happening seamlessly because of big data and blockchain. Okay, now this is one more example. This is from Wipro. They have set up a LNG trading platform for UK. Just wanted to bring it up for your visibility. This is again based on big data.
Leading global information technology, consulting, and business services company Ieee implementation of a blockchain-based small-scale liquefied natural gas trading platform for Uniper Global Commodities SE and its 100% LNG for trucks subsidiary Liqvis GM formed to address the complexity of the European SS LNG market. As a result of the implementation, commodity flow management is simplified in a market characterized by extensive manual and paper-based transactions and high operational cost. The platform implemented by Wipro involves multiple peer-to-peer trading cycle participants, enables order and supply placement, delivery of goods, validation of the state of goods and bill settlements. It further helps Uniper streamline trade by reducing turnaround time, effort and inefficiencies, enables scalability and brings visibility, transparency and trust in all stages of LNG trade. Strategically, it paves the way for Uniper to become the market maker for low-carbon modern supply of alternative fuels and decentralized energy solutions.
Yeah, that's one example. I just want to bring it to your notice where energy trading is also happening using blockchain and big data. This is a example of HSBC. We know HSBC Banking Corporation, basically the Hong Kong and Shanghai Banking Corporation. They use blockchain heavily, and today they are processing big data as well. They use R3 Corda, and they are. I think this is a typical example in 2018 where they tied up with a agricultural company, Cargill, and then they had initiated their first blockchain transaction. I think this was a trade for soybeans and from Argentina, and they had used blockchain for their system for the trading part. That's one example from the banking side. Now it is far more penetrated. It is just 3 years back, so it's far more penetrated. Just want to let you know there's an example here. And this is automotive example. They are using blockchain again, both big data and blockchain for the asset management of their cars. Basically, what it shows is it shows each of their vehicles, parts or anything serviceability is maintained as a digital ledger for each car. And BMW does it actively, monitoring this one, and that way it is seamlessly ensuring and proactively also ensuring their customers are taken care at all levels. Just wanted to show one video on that one. Hold on.
Blockchain. What's behind the technology? Instead of relying on an intermediary, the transaction is carried out correctly. Example, about a vehicle, repairs, services, mileage, etc. The blockchain technology allows us to equip each vehicle with a digital car pass. Think of it as a digital ledger, where all information about the vehicle is written into. A digital fingerprint of this ledger is stored safely encrypted by every participant of the blockchain network. The vehicle sends fingerprints of any updated information about maintenance, inspections, etc. to all participants of the network, where they are verified by comparing them to the previous version of the fingerprint. Then the verified fingerprint is stored again by every participant on the blockchain. If somebody tries to manipulate any data now, for example by changing the mileage of a used car, it will not match with the information stored in the blockchain anymore, so the fraud attempt will be recognized in the next report. Thus, the blockchain technology grants reliable information about the vehicle's history. The car owner can then share this information with many kinds of stakeholders. For example, insurance companies, workshops, distributors, or someone interested in buying a used car. The buyer of a used car, in turn, can check for the correctness of all vehicle data at the reseller via a dedicated app. There are many more conceivable applications for the blockchain technology. For example, it can help to trace raw materials throughout the whole supply chain, all the way to its source, in order to ensure ethical and sustainable extraction. Likewise, the blockchain can simplify the charging of electric vehicles, for example by permitting the car owners to charge at stations of various suppliers. Or the blockchain can enable autonomous vehicles to take care of all interactions and transactions by themselves, for example charging, paying a toll, or a parking fee. And this is just a small glimpse of the enormous blockchain technology potentials. Find more in the article on bmw.com.
Yeah, that's example. Let me move on. Like this, Mercedes have done. Rolls-Royce have done. I'm sure each of the penetration of blockchain is gone beyond now. So I'm sure even Maruti is doing it or Suzuki is doing it in India. Similarly, for banking, I just brought up HSBC, but I just recollected we have done from Intel side, we have done for our State Bank of India. I think in Karnataka, we have done a blockchain for the small medium businesses. We have established a blockchain network for their SME products. Okay, now apart from that, we have use cases in telecom. Telefonica, this is a big telecom company. They use blockchain along with big data processing. It's basically IBM blockchain platform they're using for basically validating the information collected from different networks when routing international calls. That's also one way of creating a trust network. And Deutsche Telekom, this is Germany, and they created a digital marketplace that will allow customers to map different applications using blockchain. So they've used it for that. Apart from that, they also use it for invoices, payments, etc. And then Vodafone, again, IBM platform, they have used to connect their suppliers using blockchain. So that's one application. AT&T, for their customer, they have used blockchain for any sort of product returns, upgrade, any services to customer. They have created this, and that could easily map to their supply chain and have it available quickly. So that's a value add again, and they are using blockchain. And ATAL, our own ATAL here, they have been enabling micropayments for all the services like music, mobile games, value-added services. And even for transactions. That's a telecom example of blockchain. Okay, so any questions? I don't know, I'm out of time, but I'm just wanted to finish it up. Okay, if no other, the future opportunities. These are open research opportunities which you can explore. The adaptive blockchain design for big data. It basically questions the computational power which is being drained out on every mining or every transaction. Every node has to operate equally. So how can blockchain be adaptive so that we can reduce the energy spent on creating the node consensus, whether the consensus algorithm can be done in a way that it's much more smarter. Blockchain for 5G big data. Yes, a lot of clusters of network are going to come together here. The integration will have its own challenges and how we can leverage blockchain's properties for 5G big data. So that's open area. And cloud-based big data, basically, the building information modeling is one example where different opportunities come along, and the decision making on historical data, how we can do that. That's open. And mobile edge computing, again, MEC, whether we can have a low latency response or shrink the computing power for the data processing. That's open. And SDN based big data for how blockchain can, if implemented, how it can be more flexible, agile. Again, data delivery, data processing, cloud transmission, related issues, how we can solve it. These are open areas you can look into. Of course, these are my references. And I have few slides which I wanted to show. Yeah, so we are, I think Professor Prasanna mentioned about a lot of climate impact, and we also went through a lot of challenges with the climate change, and we are victims of it. So instead of being silent, I thought of giving some elements so that at least from our side, little practices can make big differences. Like they say that the wings of butterfly can create a storm in some part of the planet, like that. So what contribution you can do? I'm not going to ask for a donation, don't worry. It will be more on your contribution from knowledge. So there is a domain called sustainable software engineering. What it means is what its goals are. Basically, the carbon emission comes from every thing in the planet. Mostly, whatever we are doing today emits carbon in some form or other. I'm not talking about the dead assets, deserts that contain carbons. For example, trees will contain carbon, and if you burn it, carbon comes out of it. And that is creating challenges for us, destroying our ozone layer and everything. But well, how does software influence that? Yeah, good question, right? That is all about sustainable software engineering. So every software you design, don't do a cut and paste, or rather inheritance from the books you read. But now for this generation or future generation or even older generation, we have to start thinking how we can control the carbon out of the product we are designing. So if you do a software, make sure your CPU cycles are consumed less, otherwise the heat will come out as carbon. So like that, every element is influenced using software. This is all about it. I've given you the links and references here. You read about it. I think there are a lot of, Microsoft has taken an initiative here to form the spec. And France is having a separate group. They are just coming out big way in this. But for organization, they are doing separately. So there's a Green Software Foundation, is a kind of an NGO. You can read about it. But these are awareness I want you to understand. Just don't write software for the sake of just serving your application needs. Beyond that, think about the climate also. Each line of code is going to emit some kind of heat or power that will transform into a carbon, and that's going to probably have. And today, it's more relevant to talk in this generation is, I think I explained about big data. I think I explained about blockchain, and you see the amount of computations happening at each node, right? Now, if I transfer to physical attributes, yes, some form of carbon is going to come out. Now, we need to start thinking in these lines. That's all about it. And that's your contribution to climate. Again, this book here is a little bit of it is marketing, but fundamentals are very strong. You can read through it, how you are or any of our current assets are contributing to carbon and climatic disaster. It's coming out very well. And they've also told remedies. It's up to you to interpret, but some are affordable, some are not. But this is something which you can, the sustainable software is something which is coming out of your knowledge and you have control. You can think about it. Read through it, please. That's one highlight I want to show. The next one is we do have a IEEE blockchain group available. I think you can go into this link and then click through it. If you want, you have to be IEEE member first. So you can click through it, read through it and understand it. And there are a lot of journals and articles are coming out. And we have a Bangalore chapter also. We do conduct seminars and forums. So a lot of paper presentations may also come. A lot of value adds are expected and it is coming out. So please look into this. That's and we have chairs here, different chairs available driving this committee. Yeah, that's pretty much it. Thank you so much. And stay safe, keep social distancing, regularly sanitize, and always wear masks at outdoors. Please educate and create awareness on the same to everyone. Yeah, that's the current coronavirus status, what we have. Thank you. Any questions otherwise?
So a lot of appreciations from the audience.
Oh, thank you.
Very informative as well as very interesting. You are taken in a very interesting way. So thanks a lot.
Yeah, that's really Apollo is loaded because after lunchtime, keeping the attention is huge. And I think I would have met something at least. So I take that exponential form of your appreciation.
You conquer, sir. You conquer the traditional thing.
Hence the lunchtime, after lunchtime. Okay, I hope I'm on time. I'm sorry, but
Yeah. Please propose vote of thanks. Sir is in our next meeting. He's having another meeting. Please propose vote of thanks.
Yeah. Okay.
Yeah. Louder. Yeah, please.
Yeah, on behalf of ATAL FDP and blockchain program conducted by Central University of Tamil Nadu, I extend a really heartily vote of thanks to our chief guest, Srinivas Bosarappu sir, who spread time from his busiest schedule to grace the occasion.
Sir is Hariharan Ramalingam.
Okay, sir. Okay.
Yeah.
My gratitude to all the speakers, Hariharan Ramalingam sir and Prasanna Venkatesan sir, and all the speakers for gracing the occasion and sharing their expertise thought on emerging blockchain technology. Today we had opportunity to hear from experts, and this will surely give us brief insight on the topic and will encourage us to influence on the blockchain technology. Moreover, your guidelines and advice on climate change is morally admirable. Thank you so much. Thank you.
thank you.
Thank you. Thank you, Hari sir. Really very interesting. We enjoyed a lot. And thanks for your continuous support.
I once again like to thank all the audience, and I hope all the links are useful. Please use it. That's the reason we have to spend a lot of effort to get you this knowledge. And overall, I appreciate the organizing committee and the staff, everyone, for organizing such a wonderful event. As Prasanna sir mentioned in the morning, the university should become one center of excellence for blockchain at some point. So have that goal. Please work towards it. And I'm there always to help. Please ask me if you need anything.
Definitely, sir. Definitely. Thank you very much. Thank you.
Thank you.
The announcement for participants tomorrow, please join by 9 o'clock. The session starts by 9:15. Don't worry about attendance here. We have the software. It takes attendance automatically. Your login, logout both will be recorded. Moreover, the feedback, you need not give individual session. If you log into ATAL, for each resource person, you have to provide the feedback separately. So thanks for your kind support. Thank you very much.